Okay, so yeah, so this is exactly what I wanted to see. This is just showing, the script sig and the script pub key and the stack, so you can see what things are being added to the stack. So, so in this, so this is okay. So what we're seeing here is a normal transaction, normal scripts, which is just a plain old script or pub key hash that you normally see. So at first the stack is blank. Then the script sig is executed. It adds pub key and the sig to the stack. And then next, dub gets run, duplicates the public key. So now we see two public keys on the stack. Then op hash 160 gets run. So it hashes that value. So now we've got a hash on there. Then it pushes the hash that's contained in the script pub key. Now op equal verify gets run. And we can confirm that they're both equal, nothing went wrong. And so it removes those from the stack. Now op check sig gets run where it says, okay, now does the signature of the transaction correspond to this public key? And if it does, it leaves the value of true on the stack. So yeah, so the only, exactly. So any questions about that? So like the only thing you would see, the key thing is that it is possible to have an invalid transaction. So it would either be false on the stack or it'd be something else somewhere along the line that invalidates the transaction. Yeah.
But we did the equal verify, it didn't push anything onto the stack.
No, the equal verify pops from the stack because what it does is it makes sure that they're equal, and if they're equal, it pops them.
Can we full screen it?
So the script always has to output true or false?
Yeah, so it has to not invalidate the transaction. So normally it just returns true.
Okay.
It leaves true on the stack.
So if it doesn't return true, or
it might either leave a falsy value on the stack, or it might invalidate the transaction. So there are two ways it could end. Like if you run op return, it just immediately invalidates the transaction without. I don't think it puts anything on the stack. But if the stack ends with a falsy value, then that also invalidates the transaction.
I see.
Does that make sense?
So you have to end the script, and you have to ensure that there's a truthy value on the stack remaining. That's basically the contract of that script.
Yeah.
Okay, and so op check sig puts the true onto the stack, right?
Yep. So op check sig, it just checks, it puts a value of true on the stack, and it does not invalidate the transaction.
But equal verify does not do that. Equal verify didn't put true.
If this slide is accurate, I don't completely remember. It probably does not. This is probably accurate. That op equal verify merely confirms that they are equal, removes them from the stack, and just does not invalidate the transaction.
If they're equal, and if they're not equal.
If they're not equal, it either puts false on the stack or it just immediately invalidates the transaction. That's probably what it does. It probably if they're not equal, it probably just invalidates the transaction immediately.
So it has a way of exiting.
Yes, you can exit without.
Terminating.
Yes, you can prematurely exit.
Okay. Thanks.
And when the transaction is invalidated, does anything get put on the stack? What gets?
I don't think so. The stack is over. If the transaction's invalidated, you can now erase the stack from memory. Yeah. So I guess it's just like, the stack can be like a piece of memory, and your program can exit while just leaving the stack the same. And you can exit, all it means is the script needs to leave a true value on the stack and exit, without returning an error code or something is effectively what it's like. There are all sorts of I don't always remember the details because there are all sorts of quirky details if you actually look at the source code. So there are weird places where things just end and stuff like that. So it's hard to remember all of the details. So if you want to know in complete detail, you just have to look at the source code. I find myself forgetting. Like I've written a script interpreter in JavaScript, and I cannot remember all the details of this stuff.
So these aren't complete transactions, right? This is just the input part.
This is So the script pub key here is from the previous transaction. So the outputs are not executed until they're spent.
Is there some higher level modeling like Python or JavaScript or something in which you can write like transactions at a higher level and it takes interpreted or compiled into the.
Yeah, so is there a way to write a transaction at a high level? So, yes. I've been working on exactly that myself. So what you can do is, I have code that you can build a transaction, you can sign the transaction, and you can run the scripts, in JavaScript. So that does exist. You can use my code. I'm not the first person to do this. There's Bitcoin.js was the first to do this a long time ago. So there's definitely ways, and I'm sure like Bitcoin.j does this as well. I'm sure it has this ability. So there are ways, like if you want to do this by hand, the easiest way is probably not Bitcoin Core, because Bitcoin Core just has poor architecture. So it's not easy to pull this code out of Bitcoin Core. But Bitcoin.j, I'm sure, makes this easy. Bitcoin.js makes this easy, and my code is another option. So yeah.
We use Bitcore. He's being humble there. Bitcore is a pretty strong open source project that Ryan was on for.
Is there something in Python as well?
Yeah, there's one called Python Bitcoin lib. It was originally written by Jeff Garzik and is now maintained by Peter Todd. So yeah, there's more than one. There's another one, a less popular one. So there are multiple. Yeah, there are a bunch. I think everybody should implement Bitcoin. If you're interested, it's very informative to do this stuff. I think that's the primary. I sort of go out of my way to implement this stuff to make sure I learn the details where possible. So that I didn't really have a whole lot of other slides. Are there any other outstanding questions or anything? We've had
So could you relate this to how money gets transferred from one address to another and kind of walk?
Yeah, so I'll try and give the philosophy of it. The homework. So yes, you can put my slide back up.
Also at a higher level, block.io, ATIF, you could use this API. It is a higher level than before.
Yeah.
If you're in the back.
Yeah. Block.io, is that it? Yes, use Block.io. Sorry, the question was, what am I answering?
Could you explain how basically money gets transferred from one address to another?
Yeah. So the idea in a nutshell is you have a transaction that has an output that requires some special script to be executed to make it valid. So for instance, I could have a blank output. That has no special requirements. If I have a blank output, there's no script, there's nothing being pushed to the stack, I could spend that by creating a script SID that pushes the value true to the stack. Okay? So the whole idea is you lock your funds, and then you require a special script to be executed that unlocks it. And the trick is, it's just, I don't know the whole reasoning behind this. I've not tried to design Bitcoin myself. I'm sure Satoshi had very good reasons for doing it this way. It works out that the thing doing the spending is executed first, and then the stack stays the same, and then the thing that locked up the funds gets executed next. So you lock up the funds by requiring you're specifying, here's the key that unlocks my funds, and then you must create the script that constructs the key. So the idea is you lock the funds and then require a special script to be executed that unlocks it. Does that make sense? I think I have not read the book Mastering Bitcoin, but I've heard it's good, and I've heard that the analogy used in that book is, rather than calling them script pub key and script sig, they're called like script lock and script unlock, which is effectively what's happening. You run your script lock, it is what locks the funds, and you must run, I guess it's you sort of create the script unlock, which must be executed following the script lock.
So the miners do the unlocking, and that's how you get your funds?
Yeah.
And they have the incentive to do that because they collect the
Yes, the miners, yes they do. They run all the scripts. You probably do not normally run these scripts yourself. It's probably just being run by the miners. And all you have to do is get a block and know that your transaction is in a block using the Merkle tree magic that I was showing before. And so you can know that you've been paid without necessarily running all the scripts. Although there are minor security implications if you do that, like the most secure way to really be absolutely certain that you've been paid is to run all the scripts yourself and validate it, and that means running a full node. Any other questions?
What API do you recommend?
I recommend Block.io. Block.io is the best API. I don't have a whole lot of experience using APIs. It depends on what you want to do. You know, I would have to research the features of whatever API. You know, I mean, it depends on what type of application you're trying to build. I think the community has built very good stuff. So there's, you know, whatever application you want to build, it may be possible to just use an API and build it and save yourself a whole lot of headache. So, but I don't know. I don't know the state of it. I'd have to research it.
Could you tell a little bit about the project you mentioned you are doing at Reddit using this technology?
Using what?
The project you are doing at Reddit using.
Okay, yeah. So the project I'm doing at Reddit. So so we're working on a project called Reddit Notes, and we're trying to give. We raised a round of investment recently, and the investors agreed to give 10% of the shares that they bought back to the community. So we're trying to figure out a legal way of giving something of value back to the community. We would just give the community shares, but we don't want to be a public company. So this would be giving shares to 1 million people would all of a sudden we'd be a public company. So what can we do of value? Well, we haven't nailed everything yet. But we're going to create something valuable that we give to the community using blockchain technology. So we would either create an actual digital asset itself. We've considered like using just Bitcoin, because we could do something like we allow people to give them, you know, a Reddit note that could be exchanged for Bitcoin or something like that. I don't know exactly what we'll do, but it'll involve this technology. I've mentioned colored coins before. We might do something where we do colored coins. We're also talking with the sidechains guys. We might do sidechain. We're basically figuring out like legally how to do this, because technologically we have a whole bunch of options. So we're being constrained by the legal side. But yeah, so that's what we're doing. What I'm like working on right now is just like basic Bitcoin software that we will use to build the software. We might have a wallet, but a lot of it's sort of up in the air. But you can see the code that I'm actually writing if you look at my GitHub page. You can see all the Bitcoin brains that will play some type of role in this. Yeah.
So when you say you might use blockchain for this, so you would have some, like whatever you figure out is a representation of value, you would have something as an input for that, and like how would that work within the blockchain?
Yeah, so one route is that we could do colored coins. So have you ever looked into colored coins? I mean, probably not everybody has. So colored coins is a way of encoding extra data in a Bitcoin transaction to color the coins so that you have extra value that's being transferred. So Bitcoins, of course, have a built-in unit that we call Bitcoin that you send around in a transaction. But you can encode metadata. You can use op-return, as I showed. There are other ways to encode metadata by, multisig is another way. You can create like a fake public key and stuff like that to encode metadata. You can use sequence numbers. Sequence numbers are not really used usually, but you can change the sequence number. Now you've got some extra metadata in there. So you can include extra metadata that says, not only am I sending a small amount of Bitcoin, but I'm also sending one Reddit note to you. So that's the idea of colored coins. The metadata sends other stuff in the transaction.
And do the miners need to understand what that
No.
is to?
The miners do not need to understand colored coins, which is positive in the sense that it works today, but the negative is that means the miners also don't validate the colored coins transactions. So if you want to know you've validly received colored coins, you have to run your own special software on top of Bitcoin that runs, the validation. So either that means you run like a colored coin node that makes sure that you've actually received colored coins, which means parsing the transactions and parsing the metadata and making sure that it's valid colored coin stuff, or you rely on a third party to do that.
So what do the miners do? They just validate that a transaction, like you sent something from A to B.
They validate that you have sent a valid Bitcoin transaction.
But but not the
They have
metadata.
no idea that you've sent colored coins.
So the
In
no
fact-
return data they wouldn't look at, the sequence number they don't care about. So if you're using that, it's up to you. So I guess that means when you say counterparties like built on top of the, you know, they're sort of implying that it's got all the security of Bitcoin, but it's not really true. It's just the Bitcoin part of that. So the actual data that they're using, it's vulnerable
Right.
perhaps.
Correct. That's absolutely right. So you're saying like colored coins are not as secure as Bitcoin for exactly that reason. The reason is the miners are not validating the colored coins transactions. So you can know the following things, like, you know, you can know at what time a colored coins transaction occurred because it's in a block. So you have the same assurance that you have at Bitcoin. You can know that it existed because it's in the blockchain. What you can't know is just because it's in a block does not mean it is a valid colored coins transaction. So the only way to validate it is you have to run extra validation to know whether it's valid. And that means, for colored coins, what it means is you have to look at the history of colored coins transactions and see that every single one of them was valid. To know that, that the one that you got paid with is valid. So yeah, the Bitcoin miners do not validate colored coin transactions.
And there are peer colored coin validators as an example, or is it generally done by one or two?
It's generally done by like a central service, like the way.
So then you're breaking away from the whole
Yeah, it's not purely decentralized.
So just in that example, if you were to provide, let's say, some Reddit nodes to, you know, potential users, you would need to then validate it. And so then the question is, why use blockchain as opposed
Yeah.
to some just database?
Yeah, so there are a few reasons. So first of all, the users would have the option of running it themselves. So it has that benefit. So that is like, you know, if they don't trust us, they can run it. They don't have to have anything to do with us. They could be somebody who doesn't like Reddit or whatever. They just have the asset, somebody gave it to them as a gift or something like that. Any software we create would be open source, so people can run it. So this is how most colored coins work today. They let you run the colored coins validation software. But in practice, most people don't. Just like in practice today, most people who have Bitcoin, they don't run a full node. It's cumbersome to run a full node. It's way easier to just leave your money in Coinbase, right? And so people voluntarily give up the decentralization. But so long as it's an option, you know, they still have the option of validating it themselves. So that's one important difference. There are other benefits you get, you know, just from just the public auditability of it. Even if people don't normally validate it themselves, they can at any time validate it themselves. So, you know, it's sort of like, you know, it's compared to like a centralized exchange or something like, you know, Mt. Gox went bust, if anybody's familiar with the history of all this stuff. Mt. Gox was the biggest Bitcoin exchange, and I use Mt. Gox. I can't believe I had money in Mt. Gox at one point. And Mt. Gox, ultimately, I still don't know what happened. I guess they're investigating it now. But they just went bust, and they lost hundreds of millions of dollars worth of Bitcoin. And maybe this could have been prevented had there been some public auditing of Mt. Gox. But even though they're a Bitcoin company, they were a centralized service. So there's no public auditing. We had no idea. Roger Ver at one point, like, audited them. He went there. We have no idea what he actually did, and I don't know if he did a good job because I don't think they had the money. So things on the blockchain are publicly auditable at any time. So even if you don't necessarily do it, maybe your friend does it. Some trusted company you have can at any moment publicly audit it and know, you know, that nobody's cheating, that it's not fraudulent. And this is getting slightly off topic, but I think in the same way that technology sort of makes older technologies obsolete, Bitcoin does the same thing, not just Bitcoin, but all this stuff, all the other, you know, what I call the crypto financial system. I think Bitcoin makes human regulators obsolete because people can do the auditing themselves. Bitcoin is a self-regulated system. Nobody has to make sure. There's no person sitting there double-checking Bitcoin Incorporated that it's not printing more than 21 million Bitcoins.
But clearly, it's really hard for most individuals to do that themselves. So then they do naturally go to something like Coinbase. So hence you lose that power right away. So
yes,
you do end up needing a regulator to regulate Coinbase, right?
Sure. So people voluntarily give that up. So that's sort of their option, right? But for what it's to answer, will human regulators be? I mean, I could probably talk about this all afternoon. But I think what will probably happen is I hope, other services will be, in fact, I think it will be, other services that, let you manage the private keys will ultimately be easier to use than putting all your money in Coinbase. I think that's how it'll play out. If not, then yeah, human regulators are still valuable. But I'm fairly confident that it won't play out that way because human regulators are expensive. And it's way easier if this stuff is done automatically by a computer. So I think in the same way that, cars do a better job than horses do, computers do a better job than humans do when it comes to auditing these systems. So if it can be done automatically, it'll just be cheaper. Yeah.
If you have an op return in a transaction, and then you have other inputs and outputs, is the op returns executed first or something, and then all the inputs and outputs are invalid?
So the op return only ever occurs in an output. And the output is only ever, the output script is only ever executed if you try to spend it. So the op return is never actually executed, right? Like if you try to put an op return in an input, it would be executed and it would invalidate your transaction. So if you tried to do that, you would never get it in a block, it's invalid. So they only ever occur in an output, and they're never executed. Because if you tried to execute it, you would be spending it, and that would be running the op return, and then that would invalidate your transaction. So it's impossible to ever spend an op return. So if you spend, if you try to put one Bitcoin in an op return output, you're never getting that Bitcoin back. There is no way to ever spend that output and validate your transaction.
But you can have other outputs next to the op return. You can have a transaction with 5 outputs, one of which is an op return.
You can have 5 outputs, and one is an op return, so there are 4 valid, spendable outputs, yes. And that's how they normally do
And
it.
it doesn't invalidate any of the other outputs?
No. It only invalidates itself.
When you choose to do the Reddit nodes, among all the things available like Ripple, blockchain, what made you choose blockchain over
Yeah, so
alternatives?
I spent,
What was the question?
so the question is, why, for Reddit nodes, why would we pick blockchain technology versus a million other things that we could have done? So I spent, I think it was about 2 months just sort of researching what all the options were. Because when I got to Reddit, I was an expert in Bitcoin 1.0, I'd like to say. And that means things like what I just talked about, transactions and stuff. I've been doing this stuff for, I guess like a year and a half now. I'm fairly new. And I didn't know anything about Bitcoin 2.0. I didn't know anything about color coins. I didn't know anything about sidechains. I had looked at Stellar and Ripple before, but never really in any detail. So I studied all this stuff. I would say, probably the #1 reason to pick Bitcoin is I think it has the best network effect. So this is why I like building on the Bitcoin blockchain versus something else. Like, a lot of people assumed we were going to make an altcoin. I think an altcoin is the worst idea that we could do because we'd be trying to build our own ecosystem from scratch when we could just leverage Bitcoin. So that's probably the #1 reason. It also has all the right technical properties. Like I think Bitcoin is secure. I don't think anybody's going to lose their money on Bitcoin. All the other options are only, they're not more secure, they're only less secure. Like for instance, I never really liked the way the Ripple protocol worked. I thought that I'm not convinced this is properly decentralized. The reason being you effectively have to trust these gateways and it's not possible for anybody to